basic items, how to interact with Arduino, how the modular interconnect with each other. Okay, what will be the hardware setup of a project, what will be the software segment of a project, how a mechanical design form actually, ultimately how this, all these stuffs like mechanical design in hardware setup, basically the electrical wire design or setup, and at last the uploading part of the program, I mean the software sections. So how these collaborate with each other, and as a result it forms one as a project. So that's the main important part, and we're actually focusing on that. Okay, so before starting the class, please. Before starting the class, we'll talk about the motor driver, the Arduino Uno, okay, and the jumper wire, and the battery. Battery. Okay, fine. So, the battery will be so in the theory sections, you have already come to know about the power consumption, ampere rating, then what? The hardware setup, the battery connections, how they forms actually, how the demand works depends upon the projects, and then the selection, the exact selection of the battery, and actually which battery is going to use for that particular project. So today we will learn about what? About the basic items of it, about the connections and all the things. Okay, fine. Let's start. So, before we start, we have already familiar with some key elements in our course. Do you know about the motor driver of the motor module? Yes. I mean, have I? You connect, directly connect in. But I have talked about this stuff in theory section, is it? Okay. So motor module or driver, say 12-volt battery, and for the jumper wires, I think it needs a 5-volt regulator. So, in the last class, in the lab section actually, you know about how the code works with the help of the IDE, Arduino Uno. Okay, so in that sections, I mean on that section, you already knew about the lines basically which is going to design for the particular motors. And for that motors, the operations will be conducted by the drivers. And to pursue the current through the devices, the driver needs some what? Energy. It means power. It means voltage and current. And that comes from the battery. Okay. So that's why to pass the electron or the current, you need some jumper wires or wires. To the source house or the powerhouse, you need a 12-volt battery. To operate the motors, you need also motors. What? AC or DC motors? All the connections have been organized for the DC motors. Okay. Motor module, DC motors, then you need a 5-volt regulator.
To regulate the
Right.
RPM of the
Yeah. So why 5-volt regulator? Because, or the back module. Why? Because you need to, cross down, you need to break down the ultimate voltages from a state to another state. So that will be like this. If you have the line diagram of 12 volt, then you have to take it down or bring it down to the 5 volt. Okay. So how this mark model operate? 7805 CET. That's the modular. Okay. How this modular operate and how this actually works? The science, the physics, and the robotics. So that's the ultimate portions of our microprocessor interfacing course. Okay. So let's jump to the main sections. That is Arduino Uno. So not an African. So that's the Arduino Uno board. Just forget of the price of it. That's the actual Arduino, and it's almost 2,000 if you want to buy the real one. And in Bangladesh you can get it between 500, 600 or 700 in your original price. Okay. Or over that, or more than that, it will be 1,000.
Yes.
Okay. Fine. So let's see. First of all, there's a very clear picture you see right now. You have some particular pins that is going to operate with this Arduino. Fine. So right now you have two motors in your hand, and I have put this question to the midterm that you can develop your sense and analyze the question and write your own course. Is it? You remember the code that I have put on your exam scripts, basically questions? That's how to analyze or operate the two motors. Yes, I've already put that code. For the particular question. I think you have already remembered that. Okay, let's skip that. So for that reason, I can say there are some sinusoidal wave over there. Do you think these pins creates AC current or something like that? So what they suggest to do with you is to make a bunch of operations with PWM, which is pulse width modulation. So you will get some pulse like this, and you can modulate your pulse in a particular range, basically not in this range, in a particular range, okay, that can distinguish the ultimate operation, the rotation, which is designed by yourself. Okay, how? Now, let's jump to the main sections. So you have to operate a motor like right now. I think I have to go like this. So it's the first part, right? I think I have to go like this, very slowly, daisy, slashy, lazy, something like that. Now I can work in very normal way. Yes, that's a very normal work. So there are 3 different speeds you can judge just within this distance. So in digital pins, what you can design in digital pins, you can just put a 0 and 1 just to ensure that it creates a value or not. Maybe it could be the high pin or the low pin. So it will on or off. It will start like this or pause. Okay, so it could be 1/0. Now, the significance of this PWM pin is something like that. You can balance, manipulate, and as well as what? Operate yourself, your optimum design. So what's the difference, right on the question, what's the difference between the analog pin and the PWM pin? Can you please tell me what's the difference between the analog pin and the PWM pin? Okay, I'm showing right now. Analog pin versus PWM pins. You will get lots of stuff over there to the Quora and any other sections. I will show a picture. That's the picture. Okay. Then it has some lagging issue or something. Is it? Okay. Let's find out the significant difference between what? Digital pin versus analog pin. Okay. Let's look at it. So digital pin is something like that. You will get 0 and 1 pulse. Analog pin is something like you will get a value of analog. Okay. So in PWM pin, you are not going to work with the analog. You are going to work with the digital, but you can modulate it. Okay. You can manipulate it. How? Let's see. This digital pin basically comes to a high and 0, and it will be 0 or 1. 0 or 1. 1, 0, 0, 1. And at this stage, it seems that it creates a null value, has no significance. That there is no significance in your operations, in your codes. Okay. And if it comes to the close to the 5 volt and low to the 0 volt, basically it offers a voltage curve that is concept to the 1, and concept to the 5 volt, which is equivalent to 1. And if you get 0 volt or 0.1 volt or 0.2 volt, that is considered to 0. So now, in analog read pin, if you nomenclature it, if you call it like, okay, now analog read pin in coding sections, what you will get? In the read, you will get a value from 0 to 1023. So that's the analog portion. You will get what? 0 to 123. There are 1024 values in the analog. So we have to play with what? We have to play with the analog versus PWM pin. So these are the analog pins, and the special digital pins are the PWM pins. So all the PWM pins basically in form of father or in form of mother, they are the part of the digital pin, but acts like what? Variations of the analog pin. Okay, so now we will see how it works. Now that's the main important, that the pulse and duty cycle, that's the PWM pin wave. Okay, so the most important part of the PWM pin is the duty cycle. How this duty cycle works? See, there is an amplitude. Okay, this amplitude offers a voltage, right? And duty cycle is concept of time. Now, just take a simple example. If you log this cycle, and you can say it's a very period of time, and then consider to t, and this period of time, what?
Full cycle.
Is full cycle, and that's the half cycle. Is it?
Yes.
So this time consumption, time variation is the part of the PWM pin, whereas this amplitude will come from the voltage. So the set of range will consider to that section, and the set of period will be considered to the time, how much time it takes to move on. Okay, now let's where is that particular sections of PWM pin? How is this? Is it this one? Yes. Okay. So if you write something in the code that is analog 0, then you will get 0% duty cycle. So it will act like what? Now offset or a DC 0 voltage, same as the digital write 0. So you will not get any kind of difference if you write analog 0 or if you write digital 0. The difference is in the coding. So this code part actually open up that pin and close that pin by using 0. If you say over there 25%, so take a calculator, and you know that there is a range of what? 0 to 255. So there are 256 values. So in 256 values of 25%, and 0.25, please put the calculator there and you will get a value of 64. Okay, so this 25% cycle means 64 is the ultimate count of 256 values. Is it? Okay. So you will get a very low pitch, a very congested area of duty cycle that is considered to your ultimate range. So what do you think if you write 64? So the duty cycle is very much low right now. So what do you think? The speed is very much higher at the time or very much lower at the time?
Speed.
Is the duty cycle considered to a very big number or a very big scale or very big portion? No, the offset term is very much bigger rather than this term. Okay, so this range and this range, is this considered to a full duty cycle, isn't it? So the on term, is it, what is this? This is the on term, and what is this? This is the off term. I mean, you can measure it from the voltage range. Okay, so this is also the off term. So in the on term section, you get a very low pitch, very low range. In the off term section, you get a very high range. So if I ask you, you have a stomach and it is filled only 25%. Do you think you are still hungry or not? You are still hungry because your stomach and your belly is not filled and your mindset is also not filled. That's because of your hungriness. Okay, so that's it. Ultimately, the speed will be very low because you don't have much oil, much food, much energy in your body in that code. Okay, so let's come to the 50%. So what will be the 50% of 56? 127. 127 times 2 is what? 256 or something? Yes, 256. So see, if I take a dot line over there, let's make it bigger. Yeah. Now it's okay. If you see the dot line over there, don't you think every time the amplitude is the same, 5 volt, that means it is on, but the pin is on, but it creates not any such significant value over there. How? Just because of you put a line over there, it is 25 and 25, so it's much bigger right now, so the speed will be higher. And after that, if it comes to 75, it is almost near of the top speed, but not the top speed. And if you think that you have the full value of 256, then you get the 100% duty cycle, and it is the same as what? The digital write 1. Okay, so in the digital write 1 and the analog write 1, in the digital read 0 or the write 0 and the analog write 0, digital write 0, the value is the same. But the difference is the effective optimization, the effective manipulation, the effective changes that you can create and put over there, that is not possible with the what? Digital thing. Okay, that's why these changes is going to be operate for a particular modular, because if you connect an Arduino with the motor, that is not going to happen. So this modular is what? Is L293. Sorry, N29N. There is different modular over there, N29N. So how this modular works actually? See, there are lots of in1, in2, basically these are the enable pins. Okay, these enable pins, this is the motor pins, out1, out2, out3, output. It's a very easy, very good easy. There are some capacitors over there, IC chip, pin block, a small switch over there. Okay, so that's the whole IC. That's not our main concern. Our concern is how is going to be connected with the motors. So if you have two motors, what you are going to do? Two motor means you have two wheels. So you can ride a bike. Okay. Now, so you have two motors. So there will be a positive term and a negative term. Is it? Is there any positive and negative term of the motor? There is no positive term and no negative term of the motor. So you have to put two wires over there, and that wires are very much important for the output, because motor is an output unit. I have discussed this in the first or second class as far as I can remember. So these are the output sections. So motor creates output. It rotates. So that's why these are out1, out2, out3, out4. So you can put two motors, four motors, make a short connection, and with a parallel connection you can operate the four motors as well. So you can save two motors over there for the particular coding that I have teach you last class. Okay, so we have the course in the laptops. Right now we have the connections. In the next class, we'll put the setup over there and upload it. Okay? Okay, so how this thing operates? You have to connect the Arduino with that. So you have, how many sections do you have? One section, that is what? That's good. So, are you clear about the PWM? Okay. There's a lot of discussion on that, and I will obviously take a bit about in the theory section. So there will be 3 blocks. Okay. 3 blocks. One block considered to what? The motor or the output. M in the motor module and the Arduino. Okay? Uno. So these motor modules have to be considered with the Arduino just to confirm that codes are going to be passed through the jumper wires, just because of to ensure that PWM are going to operate as per your coding. If it is something like that, you have mentioned in the code that Arduino is analog at 64, then the motor module must need to know, yes, it is 64. And according to that code, he has to operate the motors like that. Okay, so that 64 creates value, and it will create that value for the particular motor as a voltage. Okay, so motor understands the voltage, Arduino understands the codes, and motor module what? It will take the codes inside of it, and basically it's an interpreter. Okay, take the codes inside of it and rotate the motor as per the code or as per the text. Clear? Okay. So these motor modules will going to rotate their sections. These sections actually. Clear? Fine. Now, if I ask you how this connection built with, then I will definitely show you. So what I've talked about there is a diagonal over there. It's a HC L7805. Okay, let's talk about the L7805. I have mentioned over there, you are setting a voltage 12 volt. Okay, as I'm talking about the 12 volt, so let's finish this 12 volt battery connection. What I have talked to you in the last class, that how this 12 volt works. Basically, voltage is the basic need that comes, that is the basic beneficial needs for your body. As much as I consume the power, I need that kind of power. So the voltage range is set. Like I will take rice in the what? Dinner. I will take rice or some cookies or something at the supper as a breakfast. What it is very rare that at the breakfast we started to take heavy food. Okay, it's very rare that after the lunch time we will relaunch our lunch. Is it happening? Does this make any sense? That you are having a lunch and after that you are going to have another lunch and they are going to have another lunch. So that's very rare. It's not a normal phenomenon or normal condition. So the fact is, it is the consuming rate of yours. I need that amount of rice. I need this amount of curry or fish or chicken, whatever it is. So it's all about the demands. So the basic demand is I need food. Then what kind of food I need is my demand, my personal demand. So food is very demandable, and that is the range of 12 volt. Okay, so you are setting 12 volt to the motors that yes, this motor is going to operate at 12 volt. Okay, but the amount they choose is the particular current. It's the personal choice. Now let's make it very easier. I once worked so hard today from 9 a.m. to 12 a.m. So within 3 hours I worked a lot. That could be a physical work, or I played a lot, I played even match or football match, or I worked at the gym. Okay, so do you think today we are going to take the normal food or the conventional food? You are going to take a heavy food. You will going to drink a lot of water. You will take an extra lunch or with some fruits. So that is not normal. That is more than the conventional because we have worked hard so much. From 9 to 12, you are just sitting watching a movie. Do you think you have that kind of trust, that kind of hunger as a regular basis? Obviously no. So these hungerness, these basic needs are very much similar to the current. So the range is set at the 12 volt, but the current, the amount you need right now is what? The current or ampere. Okay, so these are the crucial amperes that you need right now. So these ampere depends on the how much work you have executed, how much how much you have sweated a lot, what kind of load or burden you have carried out throughout the hours. So that depends on the current. So this current is same goes for the motors. The amount of loads they need, so they will drag down that kind of current. Okay, so you have to set that amount of current. Okay, so to set that amount of current, and the current will be something like the consumption rate of the motor. So according to that, you have to set a 12-volt battery with a particular ampere, like 2 ampere. So maximum 2 ampere can be executed. Or if you think that you can take a motor or a battery of 3 ampere, you can take that. That's not going to be a big issue. Fine? So the 3 ampere motor is a very good build, and after that, you can work on that and work on it. And whenever you are going to connect with this motor, 12-volt connection, the fun fact is, what is the fun fact? What is the fun fact? This is the main diagram. This modular needs 12 volt. There is an extra pin of 5 volt over there. It is the output, not the input. So you have something that an LED, a buzzer or something like that, a sensor. So you can work with this 5 volt, but I recommend you not to use this 5 volt. Why? I'm going to give the answer. Okay. So this 12 volt is very much crucial. Why this is very much crucial? Just because of this 12 volt will come over there and the same as the motor, because they are not going to give us supply directly to the motors. Okay. So you have to pass the current through the motor driver, and the motor driver has the execution limit and the exceed limit, that is 2 ampere. Okay, so these prices varies just because of the ampere rate. If you have a motor driver and that has a limit of 10 ampere, it means you can pass through the 8 ampere, 9 ampere, 10 ampere easily with this driver, and that comes to the price range because there is a better IC, better heatsink will be set over there. Okay, so it's a very regular basis and a very small motor that drags down or consumes lower amount of current, so it will be easily workable or easily need to work on that. You get my point? Fine. So now, how this 5 volt comes? It's not the 5 volt this one. It is the 5 volt to connect the Arduino. So there will be the battery of 12 volt. They are going to connect with that. But here will be the 5 volt. This 5 volt is going to be the BART module. So if I explain you the BART module, all L7805CB, you understand this regulator has been set over there, and you can take the IC as a manual or as an individual and can utilize it as a 5 volt. Okay, how? Okay, so the 5 volt IC has a heatsink. So whenever they drop down the voltage, the 7 volt will appear and disappear to the environment as a air or the warm air or the something like that. Okay, so basically it follows the thermodynamics. How? The voltage convert to the what? Heat, and there's an air over there, so the heat will be consumed and the will vanish. Okay, so that's the most important thing of the heatsink. Whenever we will use this, the voltage will be dropped, and that dropped voltage 7 volt will be considered as a heat, and the heatsink will consume that particular portion as hot air or will release to the environment. Okay, that's how it works. And whenever you need to use this, because you have a set range of food, it has a hunger of 5 volt, and you can use over the 12 volt. see there is a special pin V in pin. I have talked about that. You can use 12 over there. But why should you go for this way? Go for the conventional one, the 5-volt one, or the manual input. That is very much beneficial and essential to for the smooth operation. Okay, fine. So there's a lots of pins over there. You can consider over there. So L705 has 3 sections, 3 legs. One is the ground connection, and the other one is the input and the output. So the input is something, the 12 volt, and the output you will measure with the multimeter that will consist to the 5 volt. Okay, and the ground is common to the every person that is connected to the battery and the multimeter as well. Okay, so that is the section, and ultimately the result will be something like that. Okay, so the result will be something like that. You have 2 motors, 2 output, 4 pins, PWM pins over there, 4 pin connection, and the 2 connection is the battery, and there is the ground. Okay, and to make the connection fulfill, there is another ground and 5 volt that is considered with the motor module, because this Arduino is powered by motor module. Why? Because the 5 volt is output. So you can connect the battery with this and connect the motor module as well with this Arduino. But it is not an efficient current. See, it's a project hub. You can use it, but as a project or a product, you can never use like this, never use like this, never use like this. It's a wrong setup. Because I worked on that, the device will be burned if you have a very high amount of current. So they are going to execute or withdrawing the current at that time, dragging the current. So the motor module is going to be hit, and after hitting, so it cannot passes the current over there because it is working on the load. It is depends upon this battery. How can they provide this such a smooth connection to the Arduino? You get my point? Let's see, it has 2 ampere. If this was motor concept to 0.9 ampere, so there will be only 0.2 ampere will be left. So this 0.2 ampere will be passes to that Arduino. As we can understand, the Arduino is a very low amount of current, but why will we take a risk? Who are going to give a proper connection as we are the electrical engineers? Okay, so we are not going to use this thing. Better we'll buy a back module or L7805CVIC with a heatsink. Then we will connect this Arduino. Okay, so in the next class we will build this in the class and make the proper setup as well. Okay, so that's a class, and I think you understand how this pin model actually works and how this setup is going to be set over there. Okay, so I think that's it for today. Close. Okay, thank you. Assalamu alaikum.